Hello friends, I'm Dr. Ganesh. In this series, I'm explaining about the basic principles of machine learning. And in the previous videos, you have seen a few examples of machine learning and the different steps involved in creating and running a machine learning model. We are currently seeing some of those steps. So they involve gathering data, preparing data, choosing a right machine learning model, training, evaluation, parameter tuning, and prediction. Today we are going to see the step 3 here, which is model building, selecting the right machine learning algorithm. So essentially we can broadly classify machine learning algorithms into a few types. The first very important two types are supervised learning and unsupervised learning. There is also an important category of machine learning called reinforcement learning. And in the recent past, there has been an evolution in uh, an extended version of machine learning called deep learning, which is essentially simulating our brain, how neural networks in our brain learn things. So what are different types of machine learning algorithms? Let's take that first two important categories, supervised learning and unsupervised learning. Supervised learning is nothing but whatever you learn in a school by a teacher. So, for example, the teacher will say, this is an apple or this is an orange. After a few times of learning from the teacher, you will be in a position to identify an apple as an apple, an orange as an orange. So this is essentially uses a learning where the input data uses known and labeled data as input. Whereas unsupervised learning is maybe you are simply learning by yourselves. So an example could be, I think I mentioned this example before. If you are given a mix of three different, uh, say rice, wheat, and something else, and you are asked to segregate. With no teaching involved, you will be able to segregate them into different cluster. And this does not need any education because your eyes and your brain says these are some of the distinguishing characteristics of the items that is given to me. Hence, I am able to segregate. So this is a learning that you use input data which are unknown data and you are learning as you go. Now supervised learning is quite complex in nature because you have to label, train the model using the label data. Unsupervised learning is uh, less complex in computational complexity because it deals with unknown data. Now supervised learning also needs offline analysis because you are going to label the input, categorize them into different categories, and then train the model. Unsupervised learning simply uses what is there in real time and use it. Supervised learning, number of classes. We know how many classes of data we have when we are dealing with a supervised learning because we have categorized them, we have labeled them, we know how many labels are there. Whereas in unsupervised learning, number of classes are not known. Uh, it's up to the algorithm to categorize them into different ways according to certain features that the algorithm understands. And supervised learning, since it is supervised, you can expect a high accuracy and high reliability. Whereas for unsupervised learning, uh, you could expect a slightly lower accuracy and reliability because after all it's learning by myself. On the other side of this presentation, I show you some of the important algorithms involved in supervised learning and unsupervised learning. So a typical application of unsupervised learning is clustering, where you want to simply group input data into multiple groups based on its features. Now, supervised learning typically has two expected applications. One is classification, the other one is regression. Classification, as we have seen before, so let's take them in little more detail in this video. So if we see different steps involved in supervised learning, the first step is trained using labeled examples, where the input and desired output are known. Then the learning algorithm receives a set of inputs along with the corresponding correct outputs. Algorithm learns by comparing its actual output with correct output and find errors. Then it modifies the model and it uses patterns to predict values of the label on additional unlabeled data. Very similar to how a teacher is teaching you and then you respond to a new input. So what is the difference between classification and regression? Regression gives you an output in a continuous variable line. For example, what is the temperature going to be tomorrow? You say 84 degrees or 83.25 degrees. It can be any value between the temperature range. Whereas if you look at classification, will it be hot or cold tomorrow? Classification just says the answer as yes, it will be hot, or no, it will not be hot. So it just classifies the input into certain categories. You can't have a new category. There could be hot, cold, neutral, maybe whatever, a few, not more than that. So I think the difference is clear for you. The regression can give you an answer which is in real value. They are in a continuous variable, continuous line. Classification takes values as output which are from a known set of values, only from that list, nothing beyond. A classification problem is when the input variable is a category, such as a color, a disease, or weather. It attempts to draw some conclusion from observed values. Given one or more inputs, a classification model will try to predict the value of one or more outcomes. Say classifying your email as a regular email or spam email and then put it into different folder is a typical example of classification algorithm. Whereas regression is a problem when the output variable is a real or continuous value. We have seen this example of height given weight. That is a good example of a regression model. There are different models that are used for regression. It could be as simple as a linear regression, a straight line based separation, or a logistic regression, as you can see in this image. It tries to fit with the best hyperplane which goes through the points. Now some differences between classification and regression. Classification involves prediction of discrete values, whereas regression involves a prediction of continuous values. And hence classification is the predicted data is typically unordered, whereas in regression they are ordered. And you measure the efficiency of your classification algorithm by measuring accuracy, whereas regression algorithms are measured by root mean square error. Let's take some examples. Predicting age of a person. Is it classification or regression? Regression, isn't it? Because age can take any value. Predicting nationality. Probably classification because there are only some n number of nationals countries, and the person has to be one of the n. Predicting whether stock price of a company will increase tomorrow. The answer is yes or no. Hence it is classification. Don't get confused. Predicting the gender of a person by handwriting style. Again, gender can't take more than 3 or 4 values, so classification. Predicting house price based on area. It's a price and that can take any real value, so it is regression. Predicting whether monsoon will be normal next year. I mean the rain will be normal next year. Again, this is classification because it is a yes or no question. Predict the number of copies a music album will be sold next month. What about that? The number of copies cannot take any number, so it is regression. Some of the popular supervised learning algorithms, we will see some of them as we go along, include decision tree, naive-bayes classification, support vector machine, random forest, linear regression, logistic regression, etc. Now what about unsupervised learning? As I mentioned before, unsupervised learning is that algorithm where you only have to insert input data, no corresponding output variables. The goals are typically clustering or density estimation. Step 1 is provide the machine learning algorithm categorized or labeled input data. For example, you see this image, it tries to categorize them into say cats and no cats. Oh, this is supervised learning, a mistake, sorry. Issues with unsupervised learning. Unsupervised learning is harder as compared to supervised learning tasks. How do we know if results are meaningful since no answer labels are available? Let the expert look at the results or define the objective function on clustering. Need for unsupervised learning. Annotating large datasets is very costly and hence we can label only a few examples manually. For example, speech recognition. So it is important that we also need to have unsupervised learning. There may be cases where we don't know how many classes of is the data divided into, for example in data mining. Some popular examples: k-means for clustering problems, a priori algorithm for association rule learning, PCA, SVD, ICA, etc. So to summarize, we have now seen the third step, which is selecting the right ML algorithm. Based on the feature or based on the purpose of the algorithm, we choose one. In the coming videos, we'll see how do you gain insight from the model's results and how data visualization works. Thank you.